Welcome to this CPLEX tutorial. In this tutorial, I want to implement an example in CPLEX in which I want to show you how to use some mathematical functions inside CPLEX to modify the parameters, problem parameters. And also I want to show you how we can use scripting language inside the CPLEX OPL to read and modify data. For this, I'm going to consider this example, but the main concentration is not the example. So I will not go into too much details how we formulate this problem and etc. I want to show you this modification of the parameters using these mathematical functions and scripting. So therefore, I will quickly explain the problem. Assume that there are 8 customers. So these are the customers. Each of these customers are located in the XY coordinate system, and we know their X and Y coordinates. And these are given to us, and also they also appear in an Excel file. I'm going to read this data from the Excel file. So let me show you the Excel file. So there are 8 customers, and the coordinates of the customers are given. So what we want to do is we want to locate 3 facilities, and these 3 facilities can be located to 5 alternative sites. So for the sites, again, these are alternative sites, and we know their X and Y coordinates, and in 3 of these we will locate 3 facilities. Okay, and it says that each site has a different rent index, and the rent index is also given to us. It also appears in the Excel file, and each facility has a maximum rent that it can cover, it can afford for. For example, facility 1 can afford for a maximum amount of 900 rent. It means that it cannot be located to this site 1 because the rent index is higher. It cannot be located to 2, but it can be located to 3. Okay, so depending on these rent index and maximum amount of rent that the facility can afford, we will select the locations, the sites that these facilities will be located. Okay, so the problem is to minimize the total distance between the facilities and the assigned customers to them. Okay, so let me try to explain it here with a small sketch. Let's assume that these are the customers, their XY coordinates, and we also have a number of alternative facilities. Let me sketch with red one. And to these alternative facilities, we will select 3 of them. Let's say this one, and this one. And then we will assign these customers to these facilities, to 3 facilities, so that the distance between the customers and the assigned facilities, the total distance, will be minimized. And this total distance is measured in terms of Euclidean distance, which means that it is the direct distance between the XY coordinates. So if you remember, for the first one, the coordinates are 48 and 19, and for alternative site 1 it is 27 and 60. Then the distance between the first customer and the first alternative site will be calculated by 48 minus 27 square plus 19 minus 60 square and the square root. Okay, so this is the distance between customer 1. Let's say this is customer 1 and this is the alternative site 1. So this distance is calculated in this way. So this is the problem, and let me show you how we implement it. Actually, in order not to waste time, I started implementing the model. So we have, first of all, we define the number of customers, number of facilities, and number of sites which are to be read from the data file. And I'm reading this data from an Excel file. The number of customers, number of facilities, and number of sites are read from this Excel file, and they are read from here: 8 customers, 3 facilities, and 5 alternative sites. Okay, and then I define 3 ranges to indicate the customers from 1 to 8, for facilities 1 to 3, and for sites 1 to 5. Okay, and then I'm reading the X and Y coordinates of the customers, okay, from the data file. So the X and Y coordinates, I'm reading them from the Excel file, and in the Excel file the X coordinates of the customers and Y coordinates of the customers are read from these 2 columns. Similarly, I am reading the X and Y coordinates of the facilities, again from the Excel file, X and Y coordinates of the facilities. By the way, you can calculate these distances between each customer and each site inside Excel, okay, and establish it as a matrix, the distance between each customer and each facility, and just read that information from CPLEX, and you don't need to do anything inside CPLEX. Just read it and use it in your model. But here I want to show you how to calculate these things inside CPLEX. Therefore, I'm not using it. I'm just reading the X and Y coordinates directly from the Excel file. And finally, I'm reading the maximum affordable rent and the rent index, again from the Excel file. Now let me show you the model that we are going to formulate. So we will use 3 binary decision variables. Yjk will represent if facility J is located at site K or not. Xij will represent if customer I is assigned to facility J or not. And Zijk will represent if customer I is assigned to facility J, which is located at site K. Actually, this Zijk is the a variable that we use for linearization of multiplication of Yjk and Xij, because in the objective function we need to multiply them. In order to avoid that, we need this third decision variable. So our objective is to minimize the total distance between the customers. So this Cx represents the x coordinate of the customers, and Sx represents the x coordinate of the site, and similarly y coordinates of the customers and the sites. So this is the distance between customer x and site y. Actually, there is one thing missing here. We need these I indexes here. So this is the x coordinate of the ith customer, and this is the x coordinate of the kth facility, and similarly y coordinate of the ith customers, and y coordinate of the kth facility. And we are multiplying this by Zijk. Now some of you may be confused and may say that, okay, but this is a nonlinear objective function because we have this nonlinear term here. Be careful, a model is nonlinear if it is a function of the decision variables, nonlinear function of a decision variables, either if you are multiplying 2 decision variables or taking the square or square root of a decision variable. But the thing is, everything inside this parenthesis is a parameter, Cxi. It is the x coordinate of the ith customer that we already know. It's a parameter. Similarly, Sxk. Everything inside this is a parameter. So it is not nonlinear because it does not include any decision variable. Only decision variable is this one. So some constant number multiplied by a decision variable is not nonlinear. So we have basically these assignment related constraints. Each customer must be assigned to one facility. Each facility must be assigned to one site. And for each site, we can have at most one facility. And these are the constraints related to the linearization of multiplication of Xij and Yjk. Again, I'm not going into details because the focus of this study is not the formulation itself. Now I have this constraint to satisfy the rent index and the maximum affordable rent constraint. So actually you can formulate it in a different way, but again, since I want to show you how we can modify the data inside CPLEX, I decided to formulate it in this way. So here this AJK is a parameter. Okay, so this is not a decision variable, it's a parameter, and it is a parameter that takes two values, 1 and 0. So if facility J can be assigned, can be located to site K, it will take the value of 1, otherwise it will be 0. And how we decide if a facility can be located to site K or not? Again, we decided using this rent index and maximum rent. If for a facility, if the maximum rent is larger than the rent index, then AJK will be equal to 1. So if we look, what is the value of A11? The rent index here is 900. The maximum rent of facility 1 is 900, but the rent index is 1000. So A11 is 0 because this facility 1 cannot be assigned to the first site. What about A13? So rent index is 700 in the third alternative site, and since maximum rent is larger than this one, then A13 is 1. So by just comparing these max rents with the rent index, we can find these values. But in our Excel file, we don't have that AJK. Again, by using the functions within Excel, you can calculate this AJK, but I'm going to do it inside CPLEX. Okay, so let's return to this model here. I define these three decision variables, yjk, xij, and zijk, using the ranges for facilities, customers, and sites. Now, first thing is I want to write this objective function. The objective function is this one. So it is triple summation. And then for this triple summation, we have this. So how to write this, knowing these x and y coordinates, how can I write this inside CPLEX? Let's see that one. So our objective is to minimize, and then we have summation. You don't need to write sum 3 times, but in a single sum, you can write all of them at once. So I in customers, and comma, the second one, J in facilities, and the third one is K in sites. Now this is a triple summation. And now what is the formula that I'm going to write? I'm going to write the Euclidean distance formula. So it is the square root. So simply you can use SQRT, square root. So this is an embedded function inside CPLEX, and you can use it. And as I wrote it, if you see, the color changed to purple. Then inside parentheses, I'm going to write the what is inside this square root. So remember, I need to find the difference between the x coordinates of the customers and the facilities, the sites, and square it. So in order to take the square, I'm going to use this power. Again, this pow is an embedded function, and simply, for example, if I write pow, let's say x and 2, simply it means that it's x squared. Okay, so now inside this pow, what I'm going to write inside parentheses is I will subtract the x coordinate. So x coordinate of the customer is in this parameter cust x, and it is the ith customer minus the x coordinate of the site x, and this is the kth site. So now I am going to take the power of this, I will square this. Okay, so this is the first one. Then I am going to add the second one, I mean the powers of the differences of the y coordinates. So power customer yi minus site yk, and I am going to take the square of this one and the square root. Okay, so this last parenthesis is the closing parenthesis of the square root, and I need to multiply this with our decision variables that I, j, and k. Okay, so now this is our objective function, and how we write. Look, I wrote this square root, I wrote this power. These are embedded functions inside OPL. You can use, for example, ABS, which indicates the absolute value. You can use max L, which is the maximum of something. Okay, these are embedded functions, and you can search the manual for CPLEX OPL for such embedded functions. But remember, if I write square root of, let's say, x is my decision variable, now this is nonlinear. Okay, so you convert the model into nonlinear. Be careful with these functions, you can only use the parameters. Okay, so this is the objective function, and the constraints, I already have those constraints written here in order not to waste the time. So the first constraint is summation xij equal to 1, the second one yjk equal to 1, the third one, this is the linearization. And now look, this is my last constraint in which I am using this ajk, but currently I haven't defined that ajk parameter here. Okay, so I need to define it, and if you remember, it is a 0, 1 parameter. It takes only 2 values, but it doesn't appear in my Excel file, it doesn't appear in my dot file. So I need to find the values of this parameter by myself. I only know the values of the maximum affordable rent for the facilities, and I have the rent index for the sites. The first thing is I am going to define this parameter int, I will say a, and then facilities, the first index, and the second index is the sites. Okay, so if I define it in this way and don't read its value, just define it, then all parameter values of this a will be equal to 0. So for example, now this is a complete model, and I can run the model, and if I run the model, I will get no solution from this model because all ajk values will be 0. And now look, the ajk values, all of them are 0 because I haven't assigned any values to this parameter now. And since all ajk is 0, which, according to this constraint, all yjk becomes 0, and since all yjk are 0, there's no way to satisfy this constraint, so the problem is infeasible. The thing is, I need to assign these values to these parameters, and how to do it. So we can use scripting in CPLEX OPL. It means that we can use script language and write codes inside CPLEX to modify the parameter, and as well as, maybe I will show it in another video, you can automate a process of taking runs with different data using scripting. But here I will just show a simple example. And how do we write this scripting? First thing is to write this command execute. Okay, so when you write execute, it understands that there is a scripting, and all the scripting code will be written inside these curly brackets. Okay, my code will be written here, and inside this execute you can use different types of loops, different types of assignments, and you can use if-then statements. So what I'm going to do is, now I will set the value of these a parameters. And how do I do it? I will compare the maximum affordable rent of a facility with the rent index of a site, and if the maximum affordable rent is greater than the rent index of a site, I am going to assign its value equal to 1, otherwise its value will remain 0. Currently, remember, everything is 0. Okay, and for this purpose I need to compare the maximum affordable rent of each facility with each site. So it means that I will have 2 for loops, and inside this for loop I'm going to define, look, var. So for loop, when I write for, its color is orange. It means that it understood this command. And then I am defining the index for this for loop within a var. You can use any index. Here I am going to use j, okay, and the j will take the values from my range facilities. So remember, I define this range facilities here. It goes from 1 to n facilities, so I am just defining it j in facilities. Actually, you can define this in a different way. I believe it should be something like this: var j equals 0 to, let's say, 20. I'm not sure about the syntax, but you can also define it in a regular way like you did in C++ or Java. Just you need to check the syntax. But here, since I already defined my range, I will say var j in facilities, so that it will loop through all the entries in this range facilities. And then my second loop, okay, I will again start a curly bracket here for the for loop, and for the second for loop I'm going to use var k in sites, and again start the curly bracket for this for loop. Okay, now inside this I need to compare the value of this max rent. So in order to make comparison, I need to use this if statement. If what is it? Max rent. Look, I am using these parameters that I defined before the scripting. Okay, so max rent, I already defined it for facilities, and I will say if this max rent j is greater than or equal to the rent index of site k. Okay, in this case, again open a curly bracket for this. If the value of I, j, and k will be equal to 1. Okay, so otherwise it is 0, and this curly bracket closes if this one closes this for, and this one closes the other for, and this one closes the execute. Okay, so with this line of code, now I am assigning values to this ajk1 values which satisfy the condition. All others were already 0, so you don't need to do anything for them. And if you want to see the result of this scripting, what you can do, look, currently before the scripting code, when I run the model, all a values were 0. Now let me run the model again, and if everything is correct, now we should get a feasible solution. As you can see, we obtained the solution, but now look at the values of these a's. So look, for facility 1, it cannot be assigned to site 1, it cannot be assigned to site 2, it can be assigned to site 3, not 4, not 5. And again, let me show you the data here. For facility 1, its maximum rent is 900, and it can only afford for site 3. So it can only be assigned to site 3, and it means that the values of this a parameter is correct now. Facility 2 can be assigned to or located to any one of these sites, and as you can see, facility 2 has this 1500, and it can afford all the rent indexes, and it can be located to any one of these facilities. Now I modified the value of this a parameter and I can modify or do any kind of modifications inside here. So let me show you one more thing. So as you can see at the below, there is the scripting log here. So if you do some commands, if you want to write something on the screen and etc., you can do it inside this execute statement, and all those will be written to this under this scripting log tab. So I'm going to write the values of this AJ and K on screen. Okay, so for this I use this command write-ln, write line AJK, and for each J and K it will write the values. By the way, if I want to write for each values, I should write it outside the if statement. Okay, and now if I run the code regularly, I'm running the model, and when I run it, as you can see here, you can see all AJK values, but of course it is not understandable in this way. Maybe you want to write it as a matrix and etc. So what you can do is you can write AJK, and after this you put write ln and empty write ln here, maybe with this one, and run the code again. So what it does, it writes for one row and then turns into the second line, but the thing is, maybe we should use this second one, other one. It gave an error message. Okay, I run the model again. Okay, now you see there is an error on this line. The problem is it says that write line does not exist in OPL because I started it with a capital 1. Okay, I'm writing it one more time. Yes, now it's correct. As you can see, this is the AJK value 00100, and when you do this write line and etc., you can write the parameter values and etc. inside this. If you just want to see the, let's say, positive ones, okay, all others will be 0, and we just want to see the positive ones. If I write it inside this if condition, so when I adjust the value of AJK, and I will write it directly into the screen. So what you can do is I can write this as first, let me do it in this way. I want to write the index J and then index K and then the value of AJK. Okay, so when I write it, it should write to the first column the index. And as you can see, it is confusing to understand, so it is better to put some empty lines here, empty space here. And as you can see, between each one of these, I am separating them with comma. So this is actually the format of in Java, in C++, we do the same thing. So after J, I placed one empty line here. And after K, I placed another empty line here. So whatever you write in between these apostrophes, it is just the value. So I'm writing here AJK equals to, okay, something like this. Or maybe I will write in this way. A, then J, and then K equals to AJK. Okay, so if I write it, let's see the output. It should say A13. So let me remove this empty line for a better format. And it will write A13 equals to 1, A21 equals to 1, A22 equals to 1. So this A is coming from this one, and then the second one is coming from this J index. The third one comes from this k, and the value here comes from ajk, the last one. Okay, so this is how you write these onto the screen. Okay, now we learned how to use this execute, for commands, if command, and etc. The thing is, here in our model we have these distances. We calculate these distances with such a formula, and now what I want to do is I want to convert this model so that instead of writing it in this way, just a minute, okay, instead of writing it in this way, I will just replace this with dik, with a parameter, distance ik. So simply this will be dik multiplied by zijk. So how can we do it? For this one, first I'm going to define a parameter here, and this parameter will be, of course, it will be a float because it is the square root of something. Okay, so float, this is, the first one is the customers, and the second one is the sites. Okay, and currently I don't assign any values to it. I'm not reading its value from the dot file. I'm not assigning any values. Everything is 0 currently. And inside this execute, remember this one is the end of execute. If you like, you can write commands here, end of execute. And here, if anything is grayed out, it is just commented out. So this is end of for j, and etc. Okay, so inside the same execute, now I am going to calculate the values for this dik, and again for that I will have two loops. Okay, one is for var I in customers and then I will start this. The second one is for var k in sites, again open this curly bracket. So I'm going to calculate the value of dik, and this value is actually equal to this function over here, square root of these powers. So I'm just cutting this, and instead of that I'm writing b, I, and k here, and here I'm pasting this function. But the thing is, in order to write these functions, square root, power, and etc. of such functions of the OPL model inside an execute, so I am writing it as OPL dot square root. Again, this power, it's OPL dot power, and again this power, OPL dot power. So if it is inside your model, you don't need to write OPL, but if it is inside the execute, and if you want to use these functions, square root, power, max, absolute, and etc., you need to write them as OPL dot, and be careful with the format here. O is capital, P and L is not, and OPL dot square root. And in this way I am calculating the distance between customer I and alternative site k. I have this double loop over here. So let me run the model, and as you can see, no error messages. And if I look at this d parameter now, you can see the distances between each customer and each site that are calculated Okay, they are float values, and if you like, you can just test it by manually calculating. It's always better to verify your model by just calculating it manually in these kind of parameter operations, so to understand that everything is correct. Just select randomly 2-3 of them, calculate them manually, and see if you find the same value or not. Okay, so by this way now we are writing, and the thing is, we can also write the values of these dik values. I will just write with this parameter d, I, and k. I will just close this down. I don't want to write ajk anymore. I will write this dik, and here, so if I write as right, it only writes on the same line. Okay, and then maybe I will put an empty place after this, empty space before the next one. Then when I complete writing the first row, I will go one line below, so I will write right line with just putting an empty space here. Okay, and then after completing this one line, it will go one line below to write the second line. Okay, so let me just run it, and in this scripting log now we should see the distances. Again, I wrote it with capitals, so I need to write it again. And now, as you can see, these are the distances between the customers and the facilities. Okay, so by this you learned how to use scripting, simple scripting, and how to modify the parameters inside these execute statements, and also how to use embedded functions within the CPLEX OPL. And in following tutorials, I will show you more on the scripting, how to read a three-dimensional data from the Excel using the scripting, how to write your solutions into a text file, an output file using scripting, and how to automate your model, your runs, again using scripting in the following tutorials.